Hi, hi to all of you. So today we will discuss about the another topic, that is register transfer language. In our regular computer language, so we have familiar word in the computer, that is register. So here the RTL represents the register transfer language, which is a symbolic notation to describe the micro operations which will transfers the information among the registers from register to register, or registers to variables, or variables to register. So here it will defines the symbol for various types of micro operations, and it will describes the hardware that implements these different types of micro operations. So coming to the computer registers are designated by capital letters like R1, MAR, that is memory address register, program counter, instruction register, like that. So here it will some of the times it will follow with the numerals, that is R1, R2, R3. So we have different types of different number of registers under same name. We need to use the numerals to denote the name of that particular register, and then some of the times it will supposed to denote that function of the register also. Here we have different types of names of register. So R1 in the sense it is a processor register, R1, R2, R3, so like that. And MAR, memory address register, it will holds the address of a memory unit of corresponding function. And then coming to the program counter, PC in the sense program counter, IR in the sense instruction register, SR in the sense status register. So all these are represented different types of functionalities in the computer. So coming to the there are different individual flip-flops in an n-bit register are numbered in a sequence from 0 to n-1. So here when we are observing the these two diagrams, that is R1, register R1, as well as individual bits which will be presented in the R1 register. Suppose if it is a R1 register is a 8-bit register, then it will hold the 0 to 7 bits like this. And coming to the, it will holds the 15-bit. So here numbering of bits will be represented like this, 0 to 15 bits. Some of the times it will differentiated, partitioned into the two parts, that is lower byte and upper byte. So lower byte will have a 0 to 7 bits and upper byte can have a 8 to 15 bits. That will be represented by PC of L, that is program counter of lower bytes and program counter of upper bytes. And so coming to the representation of register transfer. So here when we are observing R1 tends to R2. So here what it means, it is a transferring of information from R1 register into the R2 register. So here the transfer can be happened in one clock cycle, and the content of the R1 register will be transferred into the another register, but here the content of R1 register cannot be changed, and R2 will be lost. If there is any information, then the previous information will be lost and the content of R1 will be again transferred into the R2 register. So here R1 will be taken as a source and R2 will be taken as a destination. And coming to the conditional transfer occur only under a control condition, that is nothing but here R1 tends to R2. So here P will represents the 0 or 1. So here if clock pulse is equal to 1, then it will transfer the content of R1 into the R2. Then only. If it is 0, the transfer didn't occur. And this is the hardware implementation of R1 register, transferring of R1 register into the R2 register. So here it will apply the 1 clock pulse for transferring the R1 into R2 register. And coming to the basic symbols for the register transformation, and here letters and numerals will represents the name of that particular register and number of the particular register. So here parenthesis in the sense it will represents the part of the register, that is number of bits in the register. If it is a 8-bit register or if it is a 15-bit register, it will be divided by using the parenthesis, and arrow mark will represents the transferring information from one to another. So the left side will represents the destination and the right side will represents the source, and comma will represent comma represents the separates the two different types of macro operations, or not only two different micro operations. If there is a more than that, then it will represented by using the separated by using the comma operator.